Hi, this is part 4 of the 2057-2058 rebuild. Part 4 is going to be about working on the main circuit board here. We've already tested tubes and we've disassembled the unit and we have worked on the chassis some, and now today we're going to work on the circuit board. The specific things that you need to work on this are, of course, the circuit board. You need a copy of the service manual because it's a treasure trove of information. This happens to be an original service manual. This was printed back in the day. It even has some correction notes that were added on at the factory before it was sent out. And the thing we care about most is, while it has a lot of good information in it, the things that we care about most today are it has a nice printed fold-out schematic, which is invaluable and actually more convenient to use than trying to look at it on a PDF because you get to see the whole thing on one page. And for today's task, what we really are interested in are the pages with the parts or component lists here. And this lists out all of the different component identification numbers with their values of what the component is. And today we're going to be primarily dealing with all of the list of resistors in the unit. The things that go wrong with a board like this primarily can be summed up into or put into 3 different categories. Of course, you always have the potential that you have bad tubes, and we discovered which ones were bad when we did our tube testing in the first part. And today what we're going to be dealing with there are capacitors. And this particular model, there isn't a lot in the way of electrolytic capacitors, which are the ones that tend to fail. We have a little epoxy one down here. And we have this great big can right here. This is a multi-section can capacitor, which we'll take off the board in just a little bit and look at what it tells us. And then what else we have that goes wrong on boards like this are resistors, like this one right here. This set has a total of 51 individual resistors that span a wide range of values. These type of resistors are carbon composition resistors. They're sort of the run-of-the-mill average Joe's resistor for back in the 60s, and it's what most middle or lower priced radios would have. There were other types of resistors made back in the 60s, but these were sort of the go-to inexpensive versions. And what happens to these are their values will shift over time because they're placed under load and exposed to heat and just from age. Resistors are important in any kind of tube radio because what they're doing is they're changing voltages and they're limiting current. That's an important thing in a tube design because you don't want tubes to run too high a voltage or draw too much current. And actually you can probably see in this area on top of the board right here, I hope you can see, this area around these two tube sockets right here, it's kind of dark compared to over here. And it turns dark because it's been exposed to a higher level of heat. It may have something to do with that we have a big 10-watt resistor right here, which is used to probably drop voltage. I'll have to look at the schematic to see for certain, but likely it's to drop voltage sort of in a brute force kind of way, and this component would get hot. It's not so good that it's sitting next to our can capacitor because capacitors don't like to have extra heat around them. Here we have a little ceramic 5-watt resistor, and that can generate some heat also. But resistors are important. So what we're going to do today is we're going to remove the can capacitor and basically just put it off to the side today after we have a quick look at it. And I'm doing that now just to get it off the board and get it out of the way because it's kind of this big bulky thing in the middle and it makes working on the board a little harder. We'll deal with that in a little while. The little epoxy capacitor down here, it's not hurting anybody, and for right now it can just stay. That will get replaced. And after we get those off the boards, we're going to spend a lot of time checking resistors. So let's talk about resistors in tube radios for a second. As I said, there are a total of 51 resistors on the circuit board for the 2057, and here we're looking at the first 18 or 19, the top part of the list here, and you can see that there's a wide range of values. So each one is called out individually as to what its value is. R1 is 47K or 47,000 ohms. It's a half-watt resistor. It's rated at plus or minus 10% of the 47K, and it's a carbon, which means carbon composition resistor, which is what almost, I think all of these are, except for some wire wound resistors, which are like the big 10 watt and 5 watt ones I showed you. And you can see there's a great range of values. You have 47,000 ohms, 22,000 ohms, 220,000 ohms, another 47K, and then we drop all the way down to a lowly 100 ohm, a 330 ohm. Here we have a 10K, another 100 ohm. As we go down, here is 1,000 ohm, which would be 1K in today's language, and so on. Way down here, R19, which I think you can see, is a 2.7 ohm. So there's a wide range of resistors. There's 51 altogether. I don't remember exactly how many individual values there are, but I'm going to guess there are probably 35 or 38 different individual values throughout the whole set. And what we have to do is go through the board and check each resistor one at a time to see if the original one is still in specification. So of course, as we go through and test individual resistors, we're going to replace any ones that we find that are out of specification or show any signs of stress due to heat. Heat stress on carbon composition resistors will show up as bubbling of the epoxy closure or cracking or dulling of the finish of the resistor. And if we find any that look like that, even if they are within specifications, they're going to get replaced because they would be technically considered to be damaged. And now is our big chance to do this because we went through all the effort to take the board out. As we go through all our resistors, anything that's bad we have to replace. And the easiest way to do this, especially if you're going to work on more than one tube radio in your lifetime, is you want one of these. This is a replacement resistor kit. And these kits, there's actually two kits here. The back part is one type of resistor from one kit, and this is another set which makes up the first kit. And these resistors have individual values that match up with the types of values that are used in tube radios. So they're resistor kits for replacing resistors in tube radios. So we have two different types here. The front ones are metal film resistors, and these are rated at 1/2 a watt, just like the original ones. This particular kit, all of these, span a range of resistance between 100 ohms and 1 million ohms, or 1 megohms is what you say. This will cover a large portion of the resistors that could be in our 2057. And then back here we have a different kit, which these are larger. These are 1 watt resistors. They're a little bit larger in size. And I have these because some sets use 1 watt resistors, and also even in the 2057, there are a few resistors that usually will benefit from a higher wattage resistor. All the higher wattage means is that it's able to dissipate more heat, and the heat is from the work that it's doing. That's why the heat is generated, because it's working. And a larger resistor will dissipate more heat and do it in a better way. And these are metal oxide resistors. You'll notice I don't have any carbon composition resistors here. I don't use carbon composition resistors. While they still are available, they're not anyone's first choice really nowadays, unless maybe you're doing some sort of pristine restoration and you do it for appearance and so forth. But from a functional point of view, they're rather outdated. And one of the problems that they have is they tend to become electrically noisy as they get older, and I don't want to put them in. There are better choices. I like the metal film resistors a lot. I like the metal oxide resistors a lot for the larger size. And this larger kit spans a range of 1 ohm to 20 megohms, or 20 million ohms. So between this kit and this kit, I have every single possible value that I need to cover the 51 resistors in our 2057, 2058. And if you're going to work on tube radios, it's really better to have a kit like this. There's lots of places online that you can buy pre-sorted kits. You don't have to pick them all out yourself. Someone else has already done the hard work for you. And you buy the kit, you get all the bags. They're all labeled as to what's in the bags. And all you have to do is, as you work on your set, choose the replacement you need, and put it in place. It's much more efficient, especially because we do more of these sets, to do it this way than it is to go through, test all the resistors, make a list of what you need, then order them individually because there's no local place to go and buy them anymore, wait for them to come in, and then go back and put them all in. This way I just have everything I need. As I use up values, I order with our standard parts order replacements to restock the bags, and I always have basically a full set. So that's what the job is for today. We're going to test a lot of resistors. Before we start testing resistors, we need to get this big can capacitor off the board because it's in my way and it's bothering me. So here's how we're going to do this. We're going to turn this over and we're going to find the solder locations that correspond with the can capacitor. I know this is the large one here, and they're always basically in a circle. So I'm pretty sure that it's going to be this one, this one, this one, this one, and these four in the middle. These are not terribly large, so they won't be too difficult to desolder. This tab right here, there's always one that's larger than all the rest, and that's to index it when you place the can on the board. So what I'm going to do is see if I can set this up so it doesn't rock like that. And since this is as old as it is, one of the things that I like to do first is, before we start desoldering, it's a good idea to resolder a little bit. This solder is terribly old, and sometimes old solder doesn't flow very well. And the way that you deal with that is by adding a little bit of new solder, and it sort of mixes together and it will flow better when you heat it, and it will make it easier to desolder. So that's what I'm going to do now. And all you have to do is just go around quickly and heat up the joint and add a little bit of solder. And then we'll do the big one at the end here. That will take a couple extra seconds to heat up enough for the solder to flow. And there we have it, all touched up. Now, since we did such a good job of soldering it, now we're going to go through and we're going to desolder it. And I'm going to do most of them with my desoldering gun because that's what I use, and it doesn't really take very long to do this. Alright, and if we got it right the first time, which I hope we did, we should be able to just rock this slightly. There's sometimes when you desolder it, there'll be a slight film of solder on the joint, and if you rock it around like this, it'll break that loose, and then you can just take this and wiggle and pull it up. How good is that? We did good on that. Now, let me show you another thing, since we're talking about soldering a little bit. One of the other things that happens to boards like this. Okay, so this will be a little hard to see because that's as close as I can zoom in. But we're looking at the same general area of the board, and you can see the empty holes where we desoldered the pins for the multi-section multi-section can capacitor. And one of the things that I noticed as I was desoldering the can was this connection right here. And one of the enemies of older tube sets like this are heat and age. Heat and age will cause bad and cracked solder joints. And I'm not sure if you can see it exactly or not, but right here, this is one of the ends of the large 10-watt resistor that I showed you on the front of the board that sits between the two tubes that was next to the can capacitor. And right here where the lead comes through, and it should be soldered around on the circular pad, it's cracked. There's a solder crack, and it's really big on this side and it's rather small on that side, but it's still a bad solder joint. And that's what happens on a lot of these sets, is age and heat lead to bad solder joints. And the way you have to look at it is, this may only be what appears to be a hairline crack, and you would think, well, that shouldn't make any difference. It's almost connected. It's just a really tiny little narrow crack. But it would be equivalent to the Grand Canyon if you were an electron and you were trying to get across the hairline crack, and it's no good. I did a set just like this earlier this year, and it was a fairly straightforward repair to do. However, there must have been 30% of the solder points on the backside of the board had cracks in them from heat and vibration, and or maybe not vibration, but heat and age. And I had to go through and touch up the majority of the solder joints because of the cracks, especially around the tube socket pins, which is like, for instance, this circle right here. These are the pins that come from the tube sockets, and tubes generate heat, and the heat transfers through the socket into the board. And with all of the heating and cooling over the years since 1962, you develop solder cracks in the joints, and these all need to be touched up. So that's something that has to be done also. So let's take a quick look at our multi-section can capacitor. So this is the one we took off the board. This is probably, could be a Sprague. No, it's a Synchro. It's a Synchro MEP 50947. That's probably a part number of some kind or another. And what's inside here are capacitors. So here we have an example of two modern capacitors. We have the two blue ones here. This one is 10 microfarads at 16 volts, and this one is, it rolls around a lot. Get back here. This is 1,000 microfarads at 35 volts. So these are individual capacitors of a single value, and what we have in the can here is basically it's 4 capacitors inside a single can, and it's all one big assembly. So the way you think about this is what's inside here is a rolled up capacitor, and it has different taps within the roll. So it has a common tap, which is the common negative, and then each of the other individual taps tap into the roll and give each one a different value. So what we have in here is a 40 microfarad at 250 volts, another 40 at 250, and then we have 100 microfarad at 250 and 50 microfarad at 25. So it's 4 parts in one giant assembly. And the reason that these were used is ease of manufacturing, because all you have to do as the board goes down the production line is it snaps in place, and then it goes through the solder bath, or it's soldered by hand, and you put in 4 parts with one motion, and that was easy. So that's why these were very common. Unfortunately, these aren't really made much anymore. There is one company that makes a few, but you never are able to find the values that you need. They're always somewhat different, and they're a different size often, and they don't fit the existing spot properly, and it's very difficult. So later on, probably part 5, I'm going to show you how we deal with replacing this with modern components, because this is an important part. This filters out a lot of the 60-cycle hum or the 60-cycle noise that you get from the electrical system, and without it, the radio will hum a whole lot. So now I'm going to sit here and go through the tedious process of testing and measuring resistors. I'm going to compare them to what the parts lists say they're supposed to be. Any that I find that are bad will be replaced, and when I'm done, I'll be back. I'm not going to make you sit here and watch me measure resistors because it's really not very exciting, but I'll be back in a little while when I have it all done. See you in a bit. Hi, I'm back. Okay, so some time has passed and I've reworked and gone through and checked all the resistors. So what I found was we had a total of nine, but you can't see those. We had a total of 9 resistors that measured significantly out of specification, and all 9 of those were replaced. And while I was at it, I replaced the one little epoxy electrolytic just because it was a good time to do it. And after I got done doing that, I went through and I reflowed all of the solder joints on the entire board. As I went through and inspected them, there were a lot of them with hairline cracks in them, and oftentimes it's just easier, especially on this model, to go through and touch them all up at this point than it is to try to second guess which ones are good and which ones are bad, and then you put it all back together to try it and you realize you missed some, and you already have seen how much effort it is to take the whole set apart to get the board back out, so it makes more sense to do it now. At this point, the board is done with the exception of the large multi-section can capacitor. We're going to cover that in, I guess it'll be part 5, and we'll make that a short one to show you how I do that. And that's all for today. So the set's coming along nicely. When I get done recording this, I'm going to clean the switches on the room control board and the volume control again like I showed in the last part. That's all for today. I hope you found this interesting and perhaps helpful. If you did, please give it a thumbs up on YouTube because that always helps. There'll be a banner right here that shows how to subscribe. Click on the wheel or on the bell on our YouTube homepage. Put in your email address and you'll get notifications every time we post a new video. That's all for today. See you on the next video.